In the previous lecture, we discussed about the concept of activity and activity coefficient. Activity coefficient, it is the ratio of effective concentration to the actual concentration. That is gamma, it is equal to A upon M. We know that for ideal solution, as both effective concentration and actual concentration are same, activity coefficient it is equal to 1. But for non-ideal solution, as the effective concentration is less than the actual concentration, therefore gamma it is less than 1. So for ideal solution, A equal to M, therefore gamma it is equal to 1. For non-ideal solution, A it is not equal to M, therefore gamma it is not equal to 1. It is generally less than 1 for non-ideal solution. The effective concentration of the ion is also called as ionic activity. Let us talk about the effective concentration of the ion. So effective concentration of the ion, it is called as ionic activity. So A positive, it is equal to M positive into gamma positive. A positive, it is equal to M positive into gamma positive. You can see here activity of the cation, it is equal to M positive into gamma positive, and activity of the anion, it is equal to M negative into gamma negative. So this effective concentration of ion is called its ionic activity, as the ions are present into the solution. So they are having the activity, and that activity it is called as its ionic activity. So A positive, it is the activity of the cation. A positive, it is the activity of the cation. So let us see here, A positive is the activity of the cation. A positive is the activity of the cation, and A negative is the activity of the anion. Activity of the anion, it is called as activity of the anion. So therefore, according to the definition of the activity, it is the product of molality into activity coefficient. So we can write here activity of the cation, it is equal to molality of the cation into activity coefficient of the cation. We can also write activity of the anion, it is equal to molality of the anion into activity coefficient of the anion, where M positive and M negative are the molalities of the cation and anion, are the molalities of cation and anion present in the solution, and A positive and A negative are the activities of the cation and anion present in the solution. Activities of the anion present into the solution. Now let us going to discuss the next topic, expression for activity of the various type of electrolytes. Expression for the activities of the various type of the electrolytes. General expression now we are going to derive here. So let us consider the electrolyte of the type AXBY, general type. So this electrolyte, it is dissociated as X number of the cation A positive and Y number of the anion B negative, where X and Y are the number of the cation and anion respectively, where X and Y are the number of moles of the cation and anions produced by dissociation of 1 mole of the electrolyte AXBY. When this electrolyte undergoes dissociation, it is dissociated as X number of A positive ion cation and Y number of B negative ion. Now, if A positive is the activity of the cation A plus, A positive is the activity of the cation A plus, and A negative is the activity of the anion B minus, then the activity of the electrolyte, complete electrolyte, we should have to talk about now the activity of the complete electrolyte as the electrolyte containing both cation and anion. So it is given by activity, it is equal to activity of the electrolyte, this AXBY, it is equal to activity of the cation multiplied by activity of the anion. As there are X number of the cations are present, so we have to write here A plus raised to X and A minus raised to Y. A plus raised to X and A minus raised to Y. But we know that A positive, it is equal to M positive into gamma positive. The activity of the cation, it is the product of molality of the cation and activity coefficient of the cation. And activity of the anion, it is equal to molality of the anion into activity coefficient of the anion, where M plus and M minus are the molalities of the cation and anion respectively, and gamma plus and gamma minus are their activity coefficient. Now we know the expression for the activity, this A, it is equal to A plus raised to X into A minus raised to Y. Total activity of the electrolyte, it is the product of activity of the cation multiplied by activity of the anion. That is the total activity of the electrolyte, that is A, because that electrolyte contain cation as well as anion, and number of cations becomes equal to X and number of anions becomes equal to Y. So the derivation for the activity of the electrolyte, general derivation, this is general expression. So activity, it is equal to A plus raised to X and A minus raised to Y. But now A plus, it is equal to M plus into gamma plus and A minus equal to M minus into gamma minus. So let us substitute this A plus. So let us do here. So total activity, it is equal to put A plus, it is equal to M plus into gamma plus raised to X, and A minus, it is equal to M minus into gamma minus raised to Y into M minus into gamma minus raised to Y. Okay. So we are getting this derivation now, activity of the electrolyte. So step by step we are going to derive the derivation here. Now, what is M plus? M plus is the molality of the cation. M plus is the molality of the cation. Molality of the cation. And M minus is the molality of the anion. Suppose that M is the molality of the electrolyte. As X number of the cations are present there, what is the molality of this cation? It is X into M. What is the molality of this anion? It is Y into M. Because X and Y are the number of the cations and anions. So X into M into Y into M. So in this derivation, we can write now molality of the cation, it is equal to X into M, this, because this cation is present into the solution, and molality of the anion, it is equal to Y into M. Okay, so we can put this M plus and M minus into this derivation. So total activity of the electrolyte, it is equal to, so X into M into gamma plus raised to X multiplied by M minus, we have to put M minus here, Y into M. So y into m into gamma minus raised to y. Let us simplify this. So you can see here. So activity, it is equal to x into m into gamma plus raised to x into y into m into gamma minus raised to y. Total activity of the electrolyte. So we can simplify this. Activity, it is equal to, this is x raised to x, m raised to, we can simplify this like this. See here, activity, it is equal to x raised to x, m raised to x, gamma plus raised to x. Then another, it is y raised to y, m raised to y, and gamma minus raised to y. So let us simplify x raised to x, then it is y raised to y. So we can write here x raised to x, y raised to y, m raised to x, m raised to y. So it is m raised to x plus y. We can simplify this. So it is m raised to x plus y. So gamma plus and gamma minus can be combined here. So we can write gamma plus gamma minus raised to x plus y. So here gamma plus minus, it is the mean molar ionic activity coefficient of the electrolyte. This gamma plus minus, it is the mean molar ionic activity coefficient of the electrolyte. So this is the general expression for the activity of the electrolyte. This is the general expression for the activity of the electrolyte. Okay, you can see here. Once again, I would like to write that expression. A is equal to x raised to x, y raised to y, m raised to x plus y, and gamma plus minus mean molar activity coefficient raised to x plus y. So this is the general expression for the activity of the electrolyte. We can derive this expression according to the electrolyte AXBY, where this electrolyte, it is dissociated as X number of the cation A positive and Y number of the anion B negative. So if M is the molality of the electrolyte, so it is X into M, it is Y into M. And according to this activity of the electrolyte, it is equal to, it is multiplied by activity of the cation. Cation, it is X number of the cations are there, so it is raised to X. And activity of the anion, so it is multiplied by Y here, so raised to Y here. And as we know, activity of the cation, it is equal to M plus into gamma plus, and activity of the anion, it is equal to M minus into gamma minus. So by putting that values, activity, it is equal to M plus gamma plus raised to X, and anion, it is M minus into gamma minus raised to Y. But we know that molality of the cation, it is X into M, molality of the anion, it is Y into M. So we can put that values here. So it is X into M into gamma plus raised to X, and this is Y into M into gamma minus raised to Y. So by simplifying this, we are getting this equation. So this is the general expression for the activity of the electrolyte. Now this expression can be applicable to any electrolyte, and we can derive the derivation for the activity of that electrolyte, because there are various types of the electrolytes. So we can derive the derivation for activity of the electrolytes. So thus we derive here the derivation for the activity of the electrolyte. So activity, it is equal to x raised to x, y raised to y, m raised to x plus y, and gamma plus minus raised to x plus y, where gamma plus minus, it is called as mean molar activity coefficient of the electrolyte.